Hello, hello. Hello, hello. Hello everyone, today we'll be let me just okay hello everyone, today we'll be talking about a colorization model. This colorization model was created by myself. I'm just recreating this model to see if it works and how it works, and we will also be comparing the result with previous colorization models. Now let's see how to start. I have created a new Jupyter notebook, and let's just change the name first. What should I name it? Colorization. Now first of all, what is colorization? Let me give you an overview. Now let's see. In neural network, if we are using a neural network like convolutional neural network to do colorization, then okay, first of all, what is colorization? Colorization is the process of converting a black and white image into a colored image. So many of you may be thinking that why do we need to colorize a black and white image, or why do we need a model for that? We can try to do it using tools like Photoshop or other things. I don't think Photoshop has this feature, and if it does, it probably contains a Python a machine learning model that does that. So for the basic part, if we are using a machine learning model to colorize, then in my model I am thinking about using a convolutional neural network, and in the colorization perspective, I'll be for example, if this is an image, a basic image, normally an RGB image is consisted of 3 channels. For example, the red, green and blue, and a black and white image contains only one channel, which is one channel, so it doesn't have the 3 channel to make the photo look colorful or anything. So if this box is our black and white image, let's see, if this box is our black and white image, then our goal would be to create a colorful this will be our goal, where our final image will consist of 3 channels, which is the red, green and blue RGB channels. So our final goal for this project is to convert this one channel grayscale image into 3 channel RGB image. So this is our goal. Now there are a lot of models and lot of ways you can do that, and there is a lot of previous models that has done this, but let's see if we can come up with a new model and see if we can use that model to convert a basic grayscale image into an RGB image. So for this, what do we basically need? For this we will need a model. a machine learning model. Let's say this is our machine learning model. Colorization. This is our colorization model. So what we will be basically doing is inserting our grayscale image into a colorization model, and our colorization model will learn by itself and try to produce an RGB image. This is the basics of our project. Now most of our work will be done in this part, the model, basic model, but we will also need to do some pre-processing where we'll be using datasets to convert some images into RGB image, and in our training process we will be comparing the colored version of this image to our produced colorized images. So let's see what can we say. Now see what do we need. The first of all, we need to import some basic. We need to import some. Okay, it's okay. First of all, we need to import some basic libraries. So let's see what we'll need. Imports. First of all we'll need the torch. This torch is the Pytorch library. Pytorch is a basic one of the basic modules or packages for machine learning in Python. So it is pretty useful, and it covers most of the machine learning models and everything that a machine learning engineer will need. And from this we'll also be needing the neural network. Since we are using neural network as our model architecture, then we will be needing this. We will also be needing the Torch Vision library. Torch Vision is basically a separate package which is handled by Pytorch, and it has a lot of a lot of functionalities needed for image processing. So since we are working with images, Torch Vision is very useful. So what of next? If we are talking about looking at what our model looks like and the structure of our model, then I think this torch summary is an important package or module. What this package does is basically this torch summary package, basically if we give a model, machine learning model into this summary, then it will give us the steps the model takes to produce the results. So instead of keeping track of what you are doing in your model, this package just simply gives you what your package is built upon. Next we'll be needing models, pre-process models. I don't think we need that. Dataset, we don't need that for now. Still, let's skip it. This will be a good way to see what we have. From Torch Vision models, Torch Vision models, Torch Vision has lot of models, pre-processed and pre-trained models. We can use that to see. We can use that as a basic model, and it is used in many other processes. But let's just forget about it for now. We will talk about it later if we use it. I don't think I'll be using that for now. Then we can import dataset Torch Vision dot datasets as dt to import Torch Vision transforms as import Torch Vision transforms the transforms. This is basically a module that helps us transform a image. For example, if you want to crop an image or resize an image or randomly select a part of the image, this function helps us a lot. What else do we need? Data loader. We need data loader from Torch utils, torch.utils, data, import data loader. What do you need the data loader for? Data loader is basically a set of data. If we are giving a data set, we don't work on the entire data set at the same time. We work on part of the data set at a time. For example, if I am giving 100 images in my data set, then I won't be working with 100 images at the same time. I will be working at chunk of that data, for example 4 images at a time. This data loader helps us to select how big our chunk would be and what type of data and which data set our data will be coming from. So next will be random selector. Okay, let's do that from torch utils dot data import subset random sampler. This helps us to select which type of data, which data from the data set we are selecting. For example, in my data set I'll be keeping only one folder with all the images, and then I'll be randomly selecting part of the data for my training set, validation set and testing set. So if I my data set, if it contains 10,000 images, then if I give for example 70% data to my training set, 20% data to validation set and 10% data to testing set, this will help me do that. Next I will need, do I need the data? I need the data set from Torch Vision utils dot data import data set. This data set isn't the data set that we'll be using. This is a module. We'll be building our own data set using this module. Next we'll be needing, I don't think I'll be needing the more functionalities. Yes, we'll be needing some helper functions too. What is the problem? Data loaders. program solve. Sometimes these simple mistakes can cost a lot, so if you are using a Jupyter notebook, then try to keep it segmented. For example, I am using this segmentation only for the torch modules, and I'll be using this segment for my other helper functions, helper modules, for example. First one I'll be needing is import segmentation models Pytorch as SMP. This segmentation model is a model, for example, let's see, unit SMP. Segmentation model Pytorch. This is a helper function I am using, but what it basically does, it uses different type of architecture and encoders to create a unique model for your need. In my model, I'll be using this segmentation model Pytorch, and I'll be mostly using the UNet++ architecture and ResNet encoders. I have already tested it, and this gives me the most valid results. So let's see. I'll be also needing the most important NumPy. You will be using NumPy for most of your machine learning career. So if you need to learn more about it, then please comment below, and I may do an in-depth streaming about NumPy in the future. Import আচ্ছা খামো না, পরে খাই। Sorry about that, guys. That was my mother. Now let's start again. We'll be importing the matplotlib matplotlib dot pyplot as plt. Matplotlib is a plotting module. It is used for plotting anything you want, basically. I'll be also needing the random module CV2. CV2 is an image processing module. I don't think I'll be needing that, but just keeping it for now. What else I'll be needing from Pytorch import SSIM and SSIM. SSIM SSIM. This SSIM is basically the similarity structure similarity structure index by structure similarity index. It basically used for comparing two images and seeing the similarity between two images. I'll be using this as my loss function for training purposes. So I imported it, and what else? My zip from zip file, import zip. This is basically a zip file extractor. If I need to extract a zip file, this is the function. I'll be also needing the OS from bill. I don't think I need anything else. From I don't need that. As you can see, you need a lot of modules to create a single model. It's quite time consuming. Import. I don't think I need time. From pic import. Pic, do I need pic? Let's just keep it for now. Yes, and R, SSIM, LPIPs. These are basically image comparing models. You can search them and look on them. What else do I need? I don't need that. A good module is TQDM. Notebook has TQDM. Sorry, TQDM. This is basically for looping. If you want to see the looping process in a progress bar structure, then you'll need this. What else? Cornea. From cornea dot color. I'm adding this just for, if I need it I will use it, if I don't need it then it doesn't matter. RGB2. RGB2 lab. These are basically conversion between different image formats. Lab, RGB. And one more thing. Matplot inline. start what we need underneath. Now whenever you are working with random, it is a basic knowledge that it is preferred that you use a seed value because you will be random is chaotic and you don't want every time you open this file you don't want a different random number every time. You want randomness, but if you are training for a lot of files, then you don't want every time you reload this notebook, you don't want your randomness to change. It will be quite chaotic. So in here I just random seed. I'm just fixing the seed value for the random. Let's use 69. Let's use that. I will be fixing the random seed. And what else does have random? NumPy also has a random. So let's fix that seed as well. So my randomness will be equal in every module that I'll be using. For Torch also has randomness, so let's manual. And since I'll be using the CUDA for training purpose, let's see backend CUDA and then the deterministic. What else do I need to fix before I start? I need to fix the image dimensions, image dimension and batch size, image dim and batch size. $256. So I know that I'm doing this so I don't have to always change the image dimension in any other place if I ever want to increase or decrease the image dimension in the future. Batch size, I also need to fix the batch size. For now, let's keep it at 8. If I have more space later, then I will increase it. For now, let's keep it at 8. Now, what else? Now the dataset path. This is the path of our dataset. Let's see. I'm basically just using these images as my dataset. As you can see, we have a total of 10,505 images. I already pre-processed these images, so all of my images are what is the size? 300 by 300, but we'll be resizing these images into 250 by 250. That's why I used the image dimension variable earlier. So let's just copy this, and as you can see, if I copy that, the black space just has changed this. Yes. I have my dataset path. What else do I need? Data symbol, I don't think I need that. No, RGB, don't think I need that either. Let's now build the dataset. Color DT. Let's just keep it that. I will be inheriting from the dataset. So dataset def init self. I need a path to my dataset, so let's just keep it empty. As transform. Do I need to transform it? Let's transform it. If I need it, I will transform. For now, let's just keep it none. Self data will be. This data is the it's not the images. This data is the path to each images, each individual images. For example, this image has a path, this image has a path. Every images will be in here. Do I need a glow? Glow. No, let's just use the basic concept. Complicating it won't help. So let's just use. How do I do that? Okay. Let's just use the glob function. Import glob. Let's just see what it gives us. Glob is not defined. Oh, sorry. Okay, what is my X? I didn't give it, sorry. .jpg. All of my images are JPG. Yeah, yes, I got. These are all of the images. As you can see, these are the images. I just used a basic glob function to get all the images, and I'll be using it here. I'll be also replacing these brackets with the forward bracket, not bracket, this double slash with single slash, so just replace it. X for X in x dot replace sorry, I think there is a thunderstorm in outside, so let's just replace. What do I need to replace? 2 forwards backward slash with 1 forward slash. And this will just replace it, and we are done. We need the length. Do we need the length? Let's just, I don't think we need it. Transform is equal to transform, and change the path to our path. Def get item. This function for this is used, I will show it later, so no need for any explanation here. Now what I changed it.